Hello, pre-calc students. This is Mrs. Raposa, and I'm just going to briefly answer some questions from the 7.6 Part 1 inverse trig function. This is homework. This is not part of that homework. It's just a lead into it. I had some students in my video conference the other day asking me why do the sine inverse and cosine inverse have different outputs, different angle measures? Why do they give out different angle measures from different quadrants? And I'm going to explain why. The sine function and the cosine function, neither one of them are one-to-one. In other words, they don't pass the horizontal line test. They're not one-to-one. So I can't take their inverse if we use the whole domain of this function. But if I restrict the domain from being negative infinity to positive infinity, all angle measures, if I restrict it to just negative pi over 2 to pi over 2, negative 90 to 90 degrees, then this little piece of the sine wave, that is one-to-one. It does pass the horizontal line test. I can find its inverse. So for just this piece, the domain goes from negative pi over 2 to pi over 2. So that means that the range of the inverse sine is going to go from negative pi over 2 to positive pi over 2. Quadrant 4 angles and quadrant 1 angles. We can't use the same restriction for the cosine function because negative pi over 2 to pi over 2 is this piece right here, and that's still not a one-to-one function. It doesn't pass the horizontal line test. However, if I move it over a little bit and go from 0 to pi, or 0 to 180 degrees, this little piece does pass the horizontal line test. It is one-to-one. So restricting the domain to just that piece, I can get the cosine inverse function. So restricting the domain to 0 to pi on the cosine function becomes the range on the cosine inverse function. 0 to pi, 0 to 180 degrees, quadrant 1 and quadrant 2 angles. For the tangent function, we have to do the same thing we did with the sine wave. We have to go from negative pi over 2 to pi over 2. And it has to do kind of with where the asymptotes too are. Because some students said, well, we could go from 0 to 182 and it's still one-to-one, this piece and this piece. But we don't want to cross an asymptote because that's involved. This is not defined for the tangent function. So let's restrict it to negative pi over 2 to pi over 2. The domain for this little piece is negative pi over 2 to pi over 2 for the tangent function. That's going to become our range for the tangent inverse. We're going to get out angle measures from quadrant 4 and quadrant 1. And again, the range of the tangent function is all angle measures. This goes on indefinitely forever and in both directions. So since it's all real numbers for the output for the tangent function, that becomes all real numbers for the input of the tangent inverse. Okay, so let's take a look at the homework. For the first two problems, you were just asked to use your calculator. I didn't do that. I went and did it all out, but yeah, I should read directions too, huh? Just use your calculator. If you just put it into your calculator, you'll get these values. But however, let's just take a look at this. Cosine inverse of negative 1, that's like asking what angle measure has a cosine of negative 1. Cosine is the x-coordinate. So on the unit circle, an x-coordinate of negative 1 happens right over here at negative 1 comma 0. So we have to move over 180 degrees to get there. And remember, the sine inverse of root 2 over 2, that's like asking what angle measure has a sine ratio of root 2 over 2. And you can just put it into your calculator and get 45 degrees. Make sure you know how to put that in there. But you definitely know it's going to be a sine inverse of, is only going to give out quadrant 4 or quadrant 1 angles. Quadrant 4 or quadrant 1. This is negative angle measures. This is positive angle measures. It definitely has to be positive here because the y-coordinate is positive above the x-axis in quadrant 1. Sine inverse of negative 1/2 is like asking what angle measure has a sine ratio of negative 1/2. Again, the sine ratio is negative. Sine inverse only gives out angle measures from negative pi over 2 to pi over 2, quadrant 4 to quadrant 1. And if it's negative, it must be quadrant 4. So the y-coordinate over the radius is negative 1 over 2. Y-coordinate is negative 1. The radius is 2. That happens on a 30, 60, 90 triangle. So The 30-degree angle goes opposite the 1, so this must be negative 30-degree rotation to land us here. The cosine inverse of negative root 3 over 2 is like asking what angle measure has a cosine ratio of negative root 3 over 2. Well, cosine inverse only gives out angle measures in quadrant 1 and quadrant 2. And which one of those angle measures is the cosine going to be negative in quadrant 2? Cosine is the x-coordinate over the radius, or adjacent over hypotenuse. X-coordinate or adjacent is going to be negative root 3, and the radius or the hypotenuse is going to be 2. And again, that happens on a 30, 60, 90 triangle. That means this must be 1, and opposite the 1 is the 30 degrees. So the reference angle here is 30 degrees. So what we have here is the angle measure we're looking for has a terminal side here. So that's 180 degrees minus the 30 degrees, or 150. And for the last two problems, cosine inverse of root 3 over 2 is like asking what angle measure has a cosine ratio of root 3 over 2. So the x-coordinate or adjacent is root 3. The hypotenuse or radius is 2. That happens on a 30, 60, 90. So we have, again, a 30-degree angle here, or pi over 6. And sine inverse of root 2 over 2 is like asking what angle measure has a sine ratio of root 2 over 2, or y-coordinate of the radius is root 2 over 2, or opposite over hypotenuse, opposite that angle, root 2 over the hypotenuse 2. That happens on a 45, 45, 90 triangle. Sine is positive in quadrant 1. It has to be quadrant 4 or 1. And in this one, we knew it had to be quadrant 1 or 4. Quadrant 1 or 2. And cosine is positive in this quadrant. Hopefully that helped you.